Okay, so for worksheet 5A, like I said, we're going to be focusing on ratios and proportions and sample sets. So what a sample set is a given set of data based upon surveying a group of people. Okay, so in this scenario, it says you are writing a report about whether people use their right hand or their left hand. In the first part of your report, you will investigate the number of people in your school who are left-handed, right-handed, and ambidextrous. Who's heard of that word ambidextrous before? Okay, ambidextrous means that you can use both your left and right-handed. Because you only have 2 weeks to complete the report, you cannot ask every single person in your school which hand is his or her dominant hand. Instead, you survey or ask a portion of the students, and that survey gives you a sample of the student population. So again, a sample is a portion of the population. Now, here's the deal, guys. When we're talking about surveying and sampling, you want to make sure your sample represents a good portion. So if you're just asking only ninth graders, is that a good representation of the entire school? No. If you're just asking the people in your French class, is that a good proportion of your school? No. But if you went to lunch and asked people, that is a good sample because you have ninth graders, 10th graders, 11th graders, 12th graders, boys, girls, people who love school, people who don't love school, people who are great at sports, not great at sports, right? So that's a good sample. So that's what we mean when we're trying to find a good sample is you don't have time to survey every single person in the population, but you're focusing on a smaller group that represents the overall group well. Okay, so we're not actually going to survey. We're just going to be given the results right now. So here are the results in your chart. We have the grade first, and then the number of left-handed students, the number of right-handed students, and the number of ambidextrous students. Okay, so just analyze that chart for a moment. Ask any questions that you may have. Okay, so the first question says, how many students did we survey? So how many overall students, by looking at that chart, did we survey? Did we survey 100 people, 20 people? How many? You can chime in or type in the chat. Great. So Alyssa said, and we'll see the other person in the chat, okay, is we have a couple of different things. But what we're going to do is we're going to add the totals. So we're not going to add every single number, but notice where it says totals. That's what we're going to add up. So there was 7 left-handed, 31 right-handed, and 2 ambidextrous. So you may go ahead and, again, if you're not using this actual paper on your lined paper, make sure you're showing your work. So 7 plus 31 plus 2 gives me 40. So I surveyed 40 students. Okay. So now, and just so you understand for the rest of the chart, the numbers above, when we add the columns, the up and down, it should give me that total. So if we look at the left-handed, right, 2 plus 1 plus 3 plus 1, that gives me the 7. Then 7 plus 9 plus 7 plus 8, 31, and so forth. Okay? All right, let's keep on going. So now we can compare the results in your survey by using ratios. A ratio is a way to compare two quantities measured in the same units using division. So let's ignore the student situation for a moment and let's use this example of marbles. If you have 4 red marbles and 5 blue marbles, the ratio is 4 to 5. And we can write that as a fraction. So I'm going to circle the 3 scenarios. We can write that as a fraction. There's example 1, fraction style. We can write it with words, but using the word 2. So 4 to 5. And the third scenario is using a colon. So again, we read that really as 4 to 5, but the colon is there instead. So those are the 3 ways we're going to write our ratios: as fractions, with the word 2, or with a colon. Notice on all 3 of those examples, though, it doesn't just say 4 and 5. There's a label. It's so we actually know what we're talking about, right? If I just say 4 to 5, we don't know, are we talking about marbles? Are we talking about people? Are we talking about apples, oranges? Okay, so we're going to use our labels. So let's look at some examples. Here's that same chart again, okay? So you don't have to flip back and forth. Number 2, okay, the directions say write each ratio using division and colon. So we're going to have 2 answers, and make sure to include units. So number 2 says write a ratio of left-handed to total students. So whatever is said first goes where? The top or bottom? So it says left-handed to total. So when I do my division, what should be up top?
Left-handed students.
Whatever is said first in the statement. Yeah, okay? So in this case, left-handed comes first. That's going to be in the numerator. If it said total to left hand, then total would be in my numerator. Is that clear to everybody? So whatever comes first, that's what we're going to do first. So for the division, how many left-handed people did we say we have? We have 7 of them. So I'm going to have 7, and this is what everybody can be writing. If you're at home, please write the word division and then do what I'm writing. So 7 left-handed over, because it's division, our total. What did we calculate was our total again, folks? 40, right? Over 40 total. And if you have room, I don't have room, you can write left-handed students and 40 total students. So there's our division. How do I do that with a colon? So again, if you're writing on paper, please write the word colon and then what we're about to do. Same thing, I'm going to do the left-handed first. So I write 7 left-handed, and then the colon is the ... to 40 total. Okay, what I'm going to ask you guys to do right now is try numbers 3, 4, and 5. Don't move on after that, but 3, 4, and 5. And just like I did with underlining on number 2 what they want me to do the same thing. So on number 3, it's saying right-handed to total. So now I know what I'm looking for. I'm looking for right-handed and total. Okay? I'm going to give you guys, 3 minutes or so to complete numbers 3, 4, and 5. Do the division and colon, and then we'll check them. But everybody should be working. All right, so let's look at 3 together, and then I'll have some people participate for 4 and 5. So again, writing a ratio of right-handed to total. So I just look up at my chart. Here's where right-handed is. So right-handed's total is 31. So that's important to note that we have 31 right-handed. And what did we say total again? 40, right? So for division, I will have 31 right-handed, and if you have room to write right-handed students, even better, over 40 total. Again, if you just say 31 over 40, you're going to lose points. You need to have those labels. And then the colon is 31 right-handed, ... 40 total.
Are we going to lose points if we don't write students, or can we write like 31 right-handed? Is that like...
Yeah, that's fine. What you have the right-handed, yeah. All right, number 4. Would anybody in the chat like to tell us what you got for either the division or the colon for number 4? Go ahead in the chat, put what you think should be the answer. Either division, you can use a fraction bar, or colon, you can use the actual colon on the keyboard. Let's see what you have. Yeah, number 4. So it's left-handed to right-handed. Good. Dominic, Ashley, Aleshka, good stuff coming through. Victoria, good. Okay, so Moses, nice. Okay, so what I'm seeing here, some did with colons, some did with the fraction bars. So for left-handed, like we saw, and we've already written it, there was 7 left-handed, and right-handed, there was 31. So for division, I have 7 left-handed over 31 right-handed. Now, a few of you in the chat just typed in with the numbers. Of course, in the chat, that was fine, but please make sure on the paper you have the labels there too. And then colon, same exact thing, but we just go from left to right and using a dot dot. I'm going to run out of room, so let me write underneath. Sorry, running out of room there. All right, how about number 5? Same deal. Some people want to put that into the chart, into the chat, sorry. Ambidextrous to total. I've got 1 answer so far, 2 answers, 3 answers, 4 answers. Good, and they're looking good. Yay. Everyone who's participated so far, we're at a good start. All right, so I am seeing the following. 2 ambidextrous over, what does ambidextrous mean again? Someone chime in, someone just asked that.
People who can use both hands.
Both hands, yeah. So you can write with your right hand and left hand, or maybe like baseball is a common one. You can throw with your right hand, but you bat with your left hand. All right, so that's correct. 2 ambidextrous over 40 total. Did anyone do anything else for that problem? Or maybe you started here, but then wrote even something else? Look at that fraction. What could I do? Simplify it. Yes, Jocelyn, good. What number can go into both of these numbers, 2 and 40? 2. I could divide, okay, I'm just going to use a different color. If you left your answer as blue, it's totally fine. But I could divide both of these numbers by 2. And what would I get up top now? What's 2 divided by 2?
2.
Careful. 2 divided by 2 is 1. So I would get 1 ambidextrous over 40 divided by 2 is 20 total. So if you can ever reduce, try reducing. Okay, so we have blue is what we started with. That comes directly from the chart. But then I noticed that fraction can be reduced. So I reduced to 1 over 20. Okay? So in your homework and your assignments this week, when you see that it can be reduced, go ahead and you can write the original and then you can write the reduced version. So with the colon, we've got the same thing, just using our colon, and then we could write it as well as 1 ambidextrous to 20 total. Okay, so the orange is the alternative answer. Any questions so far? Okay, I'm just going to give 30 seconds to make sure people have copied all of that, and then we will move on. Right, so our next part is working with proportions. So what a proportion is an equation that states two ratios are equal. So we just did ratios. Ratios was a fraction, right? Something over something. A proportion is when I have two fractions equaling each other. Okay? So normally there's two ways we can do it. We can write it with the division bars, and that's the most common way. Or we can write it with the colons and then there's double colons. To be honest, we don't really use the double colon way. Our proportions will usually be set up as a single fraction equaling a single fraction. So what I want you to really focus on is 6 through 9. These are called proportions. So on number 6, 1/4 is a ratio and x over 12 is a ratio, right? It's just like what we were doing, 1/4 before we had like 2/40. So one ratio equaling another ratio makes a proportion. We want to solve for the missing values. And to do that, we use cross multiplying. Who's heard of cross multiplying before? Hopefully just about everybody. So for cross multiplying, I'm just going to get something darker, okay? What we do is we take the numerator of the first term and the denominator from the second fraction and vice versa, okay? So we have 1 and 12 will go together. And 4 and 6 will go together. 4 and x will go together. So it's not a cross multiplying, right? A cross would mean literally go left to right. Cross multiplying is we create this sort of x, and we're multiplying. So multiply one pair of those circles. One pair of those circles is, and I'm just going to write it out slowly, is 1 times 12. And the other pair of the circles is 4 times x. Obviously, if you can do the multiplication in your head, guys, you don't need to show me 1 times 12. But for your notes purpose, I'm just showing you. So then we simplify. 1 times 12 is 12. 4 times x is 4x. And now we should all be pros at solving equations. How do I get x alone? Divide, right? That's saying 4 times x. So to undo, we divide by 4. So we get 3 equals x. Okay? Go ahead. You try 7, 8, and 9. So use that cross multiplying, cross products, and solve for x in each problem. Go ahead. Good. Okay, so for number 7, anyone want to tell us what they got as an answer? Alishka? 15? Anybody agree with her? I hear a yes. Okay, let's see if she's right. So again, we do one pairing. So that's 2 times x. And another pairing across, it equals 3 times 10. So make sure you have that equal sign in between your two products. So we have 2x equals 30. And good, we're going to divide. So we get x equals 15. Good job. How about somebody else? Number 8. Who wants to tell us what they got for 8? Alyssa? Sorry, louder. 3. What do we think? Is she right?
Yes.
Yes, she is. Did anyone do anything first besides jumping to multiplication?
I divided first.
What did you divide?
12 divided by 3.
So you reduced this first fraction? And that is one thing you absolutely can do. So I'm going to show both scenarios here. So we have our cross products. Does it matter, guys, if I write this as 32 times x equals 12 times 8, or whether I put the 12 times 8 on the other side? No. Okay, please be aware of that. It doesn't matter. What matters is that you're not multiplying 32 and 8, right? 32 goes with the x, either on the left side or right side. So that gives me 32x, and then 12 times 8 is 96. And then we can go ahead and divide through by 32, and that gives me 3, which is correct. Notice though, if you don't have a calculator, so I'm going to pull orange back out. I'm just going to rewrite the problem. So this is your other option that you can do. Want to reduce a fraction first, you can do that. Then your multiplication is much smaller. So I know that 4 goes into both of these numbers. If I divide 12 by 4, it gives me a 3. And if I divide 32 by 4, it gives me an 8. Now when I do my cross product, I have 8 times x and 3 times 8. And those are just way smaller numbers now to be working with, and I still get 3. Okay? So either way, if you want to reduce a fraction first, you can. All right, let's hear from somebody else. How about somebody at home who hasn't chimed in yet? What did you get for number 9?
3.
3 again? And yes, you're correct. So we have 15x and 5 times 9. So 15x equals 45, and divide by 15 equals 3. Same deal. I could reduce if I want to. That 9 and 15 could be reduced. Any questions with cross multiplying? Remember, if you're sitting at home or you're sitting in the classroom going, I don't know where she's coming up with these numbers, then you need to be chiming in. You need to take ownership of your learning, okay? So when we're explaining what we did, it's very straightforward. First, we cross multiplied the ratios. So we did the multiplication, right? One pairing with one pairing, the other pairing with the other pairing, and then divided to get x alone. So we cross multiplied, got those products, and then we divided to get x alone. Any questions? I'll leave 10 there. It's at the top of the page. What I would like you to start to do now, because we're going to do this one problem before lunch, is I'd like you to read number 11. We're combining the two skills we've learned, coming up with a ratio from your chart and a proportion in solving. Is everybody all up to date? Okay, so number 11, we've got our chart again that we've been seeing. It tells us that there are a total of 119 students actually in the school that are left-handed. So remember, our chart is the sample, okay? This is the sample. What I have underlined is the fact that there's actually 119 students total left-handed, okay? Use a proportion and the result of the sample to predict how many students are in the school. So we're looking for, I'm going to use orange, we're looking for how many total in the school. So just walk with me here, okay? what we're going to understand is that we are comparing left-handed to total. Is that clear to everyone? Everyone needs to be paying attention. Left-handed to total. I'm going to start with my sample proportion. So how many left-handed in my sample in my chart? 7. So I'm going to have 7, and you can copy, left-handed. Again, we're comparing left-handed versus total. How many total in my chart did we say? Total from my chart? 40. 40 from my chart. So this first ratio I'm doing is info from the chart. 7 left-handed, 40 total. Now we're going to make a proportion, so an equal sign and another ratio. What has to happen is that the labels need to match. So since I have left-handed on top, I need to have left-handed on top again. Recall, my first ratio was about the chart, the sample. The second ratio now is about the total school. So how many total kids in the school are left-handed? 119. So now 119 will be up top. So again, the 7 left-handed was the 7 from the sample. The 119 left-handed is the 119 left-handed overall in the school. So notice it matches left and left. Now the bottom was total, so I need to have total. And that's what we're looking for. It says how many students were there. So that's my X. We don't know. Does everybody understand how I set that up? Now exactly. Now we just cross multiply. So I'm now going to do 7 times X equals 40 times 119. And when we get that, we have 7x equals 4,000. Hang tight. 4,760. And what's my last step? Divide by 7. Exactly. So when I divide that 4,760 by 7, did anyone get an answer? Good, 680. So what does that mean? There is a total of 680 students in the school. Okay? Once you have that written, you guys may head off to lunch, and we will come back and try 12 and 13 on our own first and then together. Okay? Have a great lunch. See you in a little bit.